Hello everyone, welcome to Explorer Hop. In this problem, we're asked to create a probability histogram for the random variable x representing the number of Allie's successful free throws if she is planning on attempting 6. She usually makes 80% of her free throws. To create the histogram, we first need to recognize that this is a binomial distribution. The value of n, in this case, is 6, and the value of p is 0.8. We're going to keep x as a variable because we're going to make a table with all of the possible values, which are 0, 1, 2, 3, 4, 5, and 6. The other side is going to be the actual probability distribution, which we can solve with the binomial formula. I'll do the first one as an example. X is equal to 0, which is 6, 0, 0.8 to the 0, times 0.2 to the n minus x, which is 6 minus 0, so 6. This is equal to 6 factorial over 6 factorial, which is 1, times 1, times 0.2 to the 6. With a calculator, we find that this is 6.4 times 10 to the negative 5. So we put that in the right spot, and we can solve all of the rest of these the same way. We just change this value here, and we find that all of them are 1.54 times 10 to the negative 3, 0.015, 0.082, 0.246, 0.393, and 0.262. Now that we have all of these, we can draw the probability histogram. So we have 0, 1, 2, 3, 4, 5, 6. And I'm going to be incrementing by 0.05 because we have some pretty small numbers. So these first two values are very small. They probably wouldn't be visible on the table. I'm just going to draw small lines just to show that they're there. And then number 2 is 0.015, which is around here. Number 3 is 0.082, which is right there. Number 4 is 0.246, so it's over here. Number 5 is 0.393, that's all the way up here. And number 6 is 0.262. We can see the characteristic binomial distribution pattern of like one peak in the middle and a decrease on both sides, but this is our probability histogram, where this is the number of free throws Allie makes. Thank you for joining us. We'll see you in the next lesson.